Good morning, children. Welcome back. Today we are going to continue with your real numbers chapter. This is the session 3 where we will be discussing exercise 1.2 from your NCERT textbook. So before that, let's revise what irrational numbers are. Okay, like I said in the previous class, irrational numbers are of the form P by Q, where provided Q should not be equal to 0, okay? Otherwise, it's an error in math. And P and Q should belong to integers. Yes? And there's one very important note that you all need to remember. If P is a prime number and if it divides some rational number A square, then it will divide A as well. For example, let's take 15 square. Everybody knows 15 square is 225. So 3 is a prime number, right? 3 divides 225. Yes or no? It divides. 3 sevens are 21, 3 fives are 15. You'll get answer as 75. So definitely 3 divides 25. That means it divides 15 square. So 3 divides 15 as well, isn't it? 3 fives are 15. So this is an important note. If a prime number P divides A square, automatically it divides A. Okay. Now, let's learn how to prove some numbers irrational. As such, we can't show it on the number line. We can, but for now, I'll show you the algebraic proof. Let us, act stubborn. Let us act stubborn and say, sorry, root 2 is rational. Okay, we will go the contradicting way. Sorry, let root 2 be rational. This is our assumption. So if it is rational, it is of the form A by B. Okay, provided B not equal to 0. And when I'm writing it in the form of A by B, that means I'm assuming they are in the simplest form. That means A and B are co-prime. Co-prime bole to their prime factor, their only common factor is 1. Okay, so this is my assumption. Hey, root 2 is not irrational. Let it be rational. That means I can express it in the form of A by B, and A by B are rational numbers and they are co-prime. That is their highest common factor is 1. Now let me do one thing. Let me cross multiply. I'll get root 2B is equal to A. Guys, now let us square both sides. I'll just write SBS for now. If I square both sides, root 2 square is 2. 2b square is equal to a square. Okay, that means, yeah, b square is equal to a square by 2. 2 divides Mr. A square. Okay, that means 2 divides a square. And just now in the previous slide, we learned that if a prime number divides a square, then it divides a as well, isn't it? So that means 2 divides a also. So if 2 divides A, can I write A is a multiple of 2? Some other number, 2C. Yeah, that means A is equal to multiple of 2. 2 is a factor of A, right? So A is equal to 2C. Now what I'll do is, I'll substitute in the above formula. 2 into B square is equal to A square. That means 2C whole square. Therefore, B square is equal to 4C square by 4. 4C square by 2. Hey, even B square is getting divisible by 2. See, B square is also divisible by 2. That means, what does this mean? It means that A square, our A and B both are divisible by 2. See, B square is divisible by 2. That means it is divisible by, therefore B is also divisible by 2. So our contradiction was, we assume that A and B should not have any highest common factor other than 1. So when our assumption itself is wrong here, how can I equate it to this? Sadly, both of them got a factor other than 1, and that is 2. So what happened? Our assumption that A and B have a HCF1 went wrong. So A and B have even 2 as a factor. So our contradiction went wrong. Therefore, root 2 is irrational. So we are proving these things by proving ourselves wrong. Okay, let's see another example. Prove that root 3 is irrational. Same stupid process. Okay, we will contradict them. Sorry, let root 3 be rational. Okay, that means it is of the form a by b, provided b not equal to 0, because error in math. Now what I'll do is cross multiply. Okay, and now I'll square both sides of this equation. So I'll get 3b square is equal to a square. Okay, a square is 3b square. So I'll put off 3 under this. Hey, a square is divisible by 3. That means a square, if it is divisible by 3, automatically even a is divisible by 3. That was by the first slide which I mentioned, that important point. That means a is a multiple of some 3. Or now I'll put some 3k. Okay, now we will do one thing, we'll substitute in this equation. Okay, so 3b square is equal to 3k whole square. Therefore, just b square is whatever by 3. Hey, b square is divisible by 3. That means even b is divisible by 3. So write the same nonsense, b square, blah, 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 divisible by 3. So blah, 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 b divisible by 3. That means, yeah, a and b both have not just 1 as a HCF. They have even 3 as a factor. A, B have 3 also as a factor. So how the hell did I contradict them? I'm wrong in my assumption that A and B are co-primes. Okay, so since I'm wrong in my assumption, my left-hand side also accordingly goes wrong. Therefore, root 3 is irrational. Okay, now let us see certain easier versions. They ask us to show that 5 minus root 3 is irrational. Okay, before doing this problem, probably we can do your exercise because I think you're well versed with this. Yes, I'll come back to these questions. Yes, prove that root 5 is irrational. It's of the same type, so we will finish this off first. Sorry, let root 5 be rational. B not equal to 0. A and B are co-prime. That means the highest common factor is 1. Chalo, now let's cross multiply. Root 5b is equal to a, square both sides. 5b square is equal to a square. So b square is equal to a square by 5. Oi, a square is divisible by 5. That means that stupid fellow a, that is also divisible by 5. Now, if a is divisible by 5, is it wrong for me to assume that it is a multiple of 5? If some number is divisible by 5, bole to it is a multiple of 5, right? So some 5c I'll put. Okay, let us substitute in the first equation. Therefore, equation 1 becomes 5b square is equal to 5c whole square. Therefore, just b square is equal to whatever by 5. Oh my goodness. B square is also divisible by 5. That means, see, c square is b square by 5. B square is divisible by 5. Just copy paste these statements. B square divisible by 5. So B is divisible by 5. That means our contradiction that A and B have HCF as 1 only went wrong itself. A and B both are divisible by 5. Therefore, our contradiction is wrong. Okay, you can write that. Our contradiction is incorrect. Therefore, root 5 is irrational. Okay, now that you've learned this, all the single numbers we are done, now we'll check for binomials, okay? These are kind of more easy. So let us assume to the contrary that 3 plus 2 root 5 is rational. So I'll say sorry, let 3 plus 2 root 5 be rational. That means 3 plus 2 root 5 can be expressed of the form a by b. Now, एक काम करते हैं, we'll send off 3 that side. Okay. So 2 root 5 is equal to a by b minus 3. And let's do one thing. Yeah, this 2 also will send off down. Wait, first I'll take off LCM. B is the LCM. Okay. Now send this fellow 2. So when it comes to the right hand side, it will come and sit in the denominator. Or in other words, you can just tell your teacher, divide both sides by 2. Now look at the funniest part. Right hand side, we have a rational fellow. A and B were rational, isn't it? Yes. A and B both are rational, B not equal to 0. So if I multiply rational number with a rational number, that will also be rational. If I multiply 2 with rational number, that will also be rational. If I subtract and divide, that will be rational. So right hand side is rational fully and left hand side, yeah, just now in the previous slide itself, you proved it to be irrational. Okay. What the hell? Right hand side is rational, left hand side is irrational. And I've marked them equal, it seems. Yeah, that's wrong. So if right hand side is rational, left hand side also was supposed to be rational. So this contradicts our fact. Okay. This right hand side fellow, it contradicts the fact that root 5 is irrational. According to us, right hand side should be equal to left hand side. So fact is getting contradicted. Therefore, 3 plus 2 root 5 is definitely irrational. Okay. Next, let's see one more. 1 by root 2. Okay. So this is pretty easy. We will again go the contradictory way. Let 1 by root 2 is equal to a by b. Rational. I'll call b not equal to 0. And a and b both belong to integers. Yeah, everyone knows integers are rational. Okay. So now 1 by root 2 is a by b. But see, right hand side is rational. Okay, wherein a and b are co-prime. Right hand side is rational. Or we can do one thing. Let's cross multiply. B is equal to a root 2. Therefore, b by a is equal to root 2. Yeah, this right hand side is rational by rational, means integer by integer, rational. Left hand side, we have already in prior, we have, in the first example itself, we proved root 2 to be irrational. See here. So what the hell? Our left hand side is not matching right hand side. Where did it go? Okay. Yeah. Right hand side is rational. LHS is irrational. So it contradicts our fact that root 2 is irrational. 1 by root 2 is irrational. You can write all the steps. Right hand side is rational. Left hand side is irrational. So if right hand side is rational, automatically left hand side should have been rational. But no, we proved it irrational. Okay, next one. Again, a binomial. See, binomial should not be a tension. It's pretty easy. Okay, so let 6 plus root 2 be some equal to a by b. Yes, first we will move the rational people on one side. I'll just take LCM. Now what can you say? See, the right hand side is completely rational because a and b were integers. See, all that you have to write the steps. A and b belong to integers, b not equal to 0 and all that. Right hand side is completely rational. So accordingly, left hand side, as per equation, even left hand side was should supposed to be irrational. Sorry, rational. But then we proved root 2 is irrational, right? Therefore, our contradiction is wrong. Contradiction went wrong. Therefore, 6 plus root 2 is definitely irrational. And I think you can try these examples. Binomial wale, same stupid story. Let 5 minus root 3 be rational. Throw 5 that side. Or maybe we can throw a by b here and push root 3 that side. Take LCM. LHS is completely rational people. So the simplification also will be rational. So in mathematics equation, LHS is equal to RHS. So root 3 also was supposed to be rational as per this. But here we proved root 3 is irrational. All right. So our contradiction in the first place itself went wrong. Our assumption is wrong. Therefore, 5 minus root 3 is irrat. Same procedure here. Prove that 3 root 2 is irrational. I'll say sorry. Let 3 root 2 be expressed in the form a by b. B not equal to 0. A and B belong to integers and are co-prime. तो एक काम करते हैं. We'll leave this root 2 here itself. Let us send off 3 down. Guys, A is integer, B is integer. Integer by integer gives us integer. That means right hand side to bichara it is rational. As per mathematics equation, right hand side is equal to LHS. That means root 2 also is supposed to be. That means LHS also should be rational. Because as per mathematics equations. But yaar, we proved root 2 is irrational in our previous slide. But root 2 is irrational. So our assumption is wrong. Our assumption is incorrect. Hence, 3 root 2 is supposed to be irrational itself. Thank you. Tomorrow's class, next class actually, we will be doing some practice PYQs, previous year questions. Okay, even 1 mark MCQs.